Hello Ditch old timers, this is Tony Gordon, 72 year at Ditch. I'm blaming John Goody for for having to bore you for the next, I don't know, 10 minutes or so with my overview of an interesting and challenging and probably the most rewarding piece of machining I've ever done in my entire career. But it starts, of course, with meeting a man in a pub, as everything does. But we need some context to make that work. The Margaret Thatcher and John Major and their efforts to develop Ofsted meant that I left the job of my dreams, which was the advisor for D&T in Staffordshire. But Staffordshire decided they were going to check into Ofsted lock, stock and barrel, and instead of being supportive and evaluative, they were going to go into the judgmental and league tabling way that Ofsted was going to be run. Cheshire and some other LEAs decided they were going to stay with the supportive and evaluative with a buy-in option. Staffordshire didn't, so I had no choice but to leave. I'd already got some very, very good contacts in America, and since I had done my Masters in America, thank you Staffordshire for paying for my sabbatical, I already had a number of irons in the fire. So we ended up moving to Michigan in 1993, and I worked there till 2016 when I retired. And in 2016 I moved down to Wilmington, North Carolina, where we bought a home which actually had a 5.5 meter by 10 meter workshop. The guy there had previously built race cars. When we lived in Michigan in 2007 through 2009, you could buy machine tools for pennies on the dollar. The lathe that you can see in this photo cost me $500. The milling machine that you'll see in a moment cost me $3,000. The machine tools were so cheap. There's the mill in the corner, the CNC mill. They were so cheap you could rig a workshop up for almost nothing. So it was very easy for me to set up a nice workshop. I hadn't retired, so all of this stuff was actually in a storage unit up in Michigan until we moved down to North Carolina, and then I was able to set up my workshop. That brings me back to the man in the pub. Donny Kaysen was one of the guys I'd met when I was hanging out in a local pub, and found a bunch of guys that seemed to like me and I liked them. And he ran a company that built sportfish boats. Sportfish boats are luxury toys for the 1%. They start at 4 million and they go up from there. So if you want a 40-foot, 6-foot sportfish boat, better have 4 million in the bank. But Donny was an interesting person. It was fun to talk to him because he basically built boats. They're not glass fiber hulls. They're triple laminated cross-ply boats. Super light, super fast. These are 50, 60 mile an hour boats that can deal with, I don't know, 2-3 meter waves. But nice guy. This is the interior of the boats they build. Absolutely spectacular. You can see in the engine room there, 2 1600 horsepower Caterpillar diesels. I mean, the fuel bill for running these things for an hour would probably empty most of our bank accounts pretty quickly. But if you have to worry about the cost of fuel, you shouldn't be buying these kind of boats. But Donny had chatted to me about making Hawse pipes. And you're probably wondering what they are, but that little red box on the right hand side of the screen, you can see that young man. feeding a mooring line, a stern mooring line, through the hawse pipe aperture. Now, Donnie didn't like the fact that most hawse pipes on the transoms or on the stern of a boat were either on the transom or they were along the side of the boat as it ran forward on the hull. He wanted them on the corner, which meant they were very difficult to make. So he had made them himself in-house and had made a horrible job of it. So he asked me, would I be interested in making hawse pipes? So the first set were actually made by my daughter with my help. She was in transition from her work in Austin before she went to Barcelona, but she was got a degree in graphics, etc., but was a very, very accomplished welder and 3D sculptor. So she actually started on these projects here. We found a really good TIG welder nearby who did the welding. But basically it was a 6-inch pipe, 150mm pipe, with a flange that we bent. We had to CNC machine the bucks and the dies and bend them to shape. But all done using CAD, but that's not really the most interesting part. It's when we get on to where Donnie went next. One day he asked me, or he said to me, you've got a CNC mill, why don't we machine these pipes? And I don't know, I said yes, and boy did I end up with a project that was probably the most complex I've ever dealt with in my professional machining career, which is, I must admit, very short. We first of all started off with looking at how you model the surface of the boat, both inside and outside. This is the starboard side, the right-hand side of a boat called Blood Money. It wasn't called Blood Money at that time, it was unnamed. But it was a 64-foot boat, and you can see where the hawse pipe hole has been bored through from the outside of the hull through to the inside. And it's a custom boat, so the curves on the other side are different. Donnie had been using photogrammetry tools for a long time to machine parts. He'd got a very comprehensive CNC routing system in his shop, but I'd never come across it, so we used that to map the hull. Once we got the hull mapped, we were able then to work out what was the curvature on the tube that passes through the hull, because without knowing what the shape of that was, it would be very difficult then to be able to put the flanges onto the two pieces. But much more importantly, not only would it be important to do that, it meant we could also work out the alignment between the outer and the inner and the distances between them. So this was the tube. The photogrammetry, incidentally, you'll see a little bit more of that in a second. The photogrammetry was used then to, they made flanges and pulled them off the hull. So this is a inner flange. So they laid it up, let it set, pulled it off, and then cut the perimeter to be about 60mm all the way around to give us the shape of the hull. This had to be done on both inner and outer, on port and starboard. So we've got 4 of these things. The photogrammetry was then used, and you took probably 100 to 150 photos, digital photos, from every single angle and then fed them into the photogrammetry software, and that produced a 3D image of this particular object that could be then fed into a CAD package. Here is the port outer. You can see the curvature of the outside of the hull. You can see where the sleeve or the tube runs away from that. Very, very time consuming. This probably took, I don't know, 2-3 weeks to do all of this. Not full time, but took a while. Once we got those all created in 3D images, I was able to then put them into Fusion 360, which is the CAD system I use. Very, very comprehensive. So much nicer than just the old 2D drawing techniques that I used. Even though I taught A-level technical drawing, boy, this makes life so much easier. But anyway, so we produced the drawings in CAD, and we could then move on from there. But CAM is the next phase of this, and you can actually see here a toolpath map. Let's have a look. It looks like that's a finishing cut using a 16mm ball-nosed cutter, and you can actually see, you know, its predicted paths. I ran this for every single cut before it ever went on the machine. You had to know that everything was going to be fine. The simulations, incidentally, will also show you if there's going to be any tool challenges, any tool clashes, any collisions with unmachined material, etc., etc. So it's a pretty comprehensive system. But you actually see this. It actually says that finishing cut is going to be a 12-hour cut. And the roughing cut that preceded it was going to be 7 hours plus. So what you're looking at there is 19 hours. But if I was leaving the machine unmanned, unobserved, I would cut it down to 50% feed rate so that it reduced the risk of any problems. So that basically meant we're looking at a 38-hour machining cuts for this one part. Now you may understand why this took 2 months to do from beginning to end. I don't have any of the raw billets as they were delivered. They were delivered as a solid piece. The hole in the middle wasn't there. They weighed 47 kilograms, 177mm diameter, 7 inches, 8 inches, and 150mm in length. Heavy as hell. The first thing I had to do was to cut the centers out, but my machine shop isn't anywhere near capable of doing this level of work. So Donnie called in a few favors, and I was able to use the machining facilities over at Edwards Incorporated in North Carolina. Very, very large crane hire company. They have the largest crane on the east coast of the US by all accounts. Superb fabrication and construction facilities there. This is their water jet cutter. It will cut through 200mm of stainless steel. 200mm. The cutting medium is garnet, which is obviously a precious stone, but apparently it's cheap and you can get tons and tons and tons of it from South Africa. So they were cutting that using garnet. Here is a quick video of this thing at work. The next, once it came off the water jet, the next phase was the face to length, and also to then finish to internal diameter, final ID. The water jet, because even though it's a pretty powerful machine, there's some trail, some bend in the cut, so you have to leave about 6-8 mil in there for machining tolerance. So here we are on a standard manual lathe cutting this down. You have to use carbide. 316L is horrible stuff. If it gets hot, it'll work harden. And if it work hardens, it doesn't matter whether you're using carbide or diamond or whatever you're using, you're not going to cut it. So you have to be really, really careful. But once I've got all 4 of the billets, then they could go into the mill and then start machining. Here you can actually see a start of a roughing cut. I was using a Hawse VF1, which is actually a lightweight machine or a low power machine for Hawse. The bed and all of the the internals are the same as the VF2, but it has a relatively small motor. It's only 3 wheels. Okay, this is the end of a finishing cut on one of the outers. You can actually see it's fairly rough where the steps are still left in there, where the previous cutter goes through and does all of the cuts. The roughing cuts, they were, I mean, it's basically hogging cutting. The finish cutter, however, is the one that does all of the work, and you can actually see it has to be 16 mil so that it can actually make the curvature at the root of the curvature between the flat flange and the vertical sleeve, which meant it was really problematic. I was using 175 mil cutters, way out. Which meant very light cuts, very long duration cuts, but even then there would be deflection, so every single finish cut had to be run twice. Now thankfully this mill was so rigid and so well tuned in that she would repeat the cuts perfectly every single time. Here's that same operation after the cut has finished. You can actually see now how all of the steps have largely gone. Because this was an inner face, in other words, this piece here faces the hull, I didn't have to be too worried about those slight ribbing around the core of the inner and outer, the sleeve and the flange. So I could leave it like that. Once the that part was cut, I had to flip it over, and you can probably see on here there's a stainless steel ring around the bottom. Because this was now so thin, or the sleeve was so thin, I had to make sure that it was protected. So there was a plug inside that was machined to the exact diameter of the ID. You can actually see it sticking up just on that right hand side. And then I put a sleeve around the outside to protect the sleeve from any marking or anything else, and then cranked it in. The sleeve had to be everything had to be indexed so that the outer cut aligned with the inner cut, so that when you can actually see, you've got to maintain that thickness of that flange. So that took some care to actually set up. But here it is in the machine, having done a roughing cut on that that surface there. This is the final cut with the finished cut now complete. So you can now see how you can see the inner sleeve inside there now. You can actually see how all of this has been now finished, and we're now at the point where that part could be seen as being complete. Let's just have a look. And here it is. This has come out. This is outside of the Edwards shop. All I've done is wipe this down to get the blue coolant stains off it. This is as machined. Now, when it gets back to Donnie's yard, his guys will polish this to high polish. You have to polish stainless steel. If you don't polish it, it will tarnish. It requires polishing so it can withstand the salt conditions in while at sea, and so they polish every single inch of this inside and outside so that it will actually not tarnish over time. But this is the first part. So what you're looking at here altogether is $2,500 worth of machining work. Each one was $2.5 grand. When I finished that job, I put some of that money into putting the storage area above my workshop into use. And here you can see the Frog and Sprocket English pub that is over my workshop, and that we obviously spend some happy times in. Here's me pulling a pint with a real English beer engine from a pub in Reading owned by some very good friends of ours. And unfortunately I'm not pulling London Pride, but the label looks good all the same. This is actually from a local brewery that do cask ales. But finally, I hope you've enjoyed my overview of this whole project. As I mentioned earlier, it's probably the most rewarding piece of machining I've ever done in my life. And I'm very proud of how it turned out.